Okay, now in this question, we're basically just being asked to work out or show that the voltage of this is going to be 7.8 volts. Now, as an electron goes around the circuit, it has to use all of the 12 volts. So if we know that the voltage used is here was 4.2, then we know whatever voltage is used on this component must add up to 12. So simply 12 volts minus 4.2 equals 7.8 volts. Now, the current at every point in this circuit is going to be the same because it's a series circuit. Now, that means if we work out the current going through this resistor, it's going to be the same as the current through that resistor. So using V equals IR, if we know that this voltage is 7.8 volts, we divide by 20 ohms, we get a current of 0.39 amps. Okay, so this is now working out the second one. Sorry, that's question is there. So that therefore means if we know that the voltage on this one is 4.2 volts and we know the current is 0.39 amps, we can again use V equals IR to do a calculation. So if we go 4.2 volts and we divide by 0.39 amps, we end up with 10.76 ohms or 10.8 ohms. We just do it to 3Sef. Okay, so that's question B. So question C gets a little bit more involved. We've added this device here. Now there are a few things that we can say about that. One, if you add a device in parallel, whatever that might be, that means the overall resistance, the total resistance rather, the same thing really, is going to decrease. And you could actually work that out and show that. Even without, you could basically make an assumption about that device's resistance. If you make it the same as the resistor here, you could work it out by doing it in parallel. Now that means that the total current is going to increase. So at this stage, it may seem very straightforward, but what happens over here? Now, before we look over there, we need to consider what's going on next door. So in the 20 ohm resistor, its voltage is current times resistance. Now, if the current has increased and the resistance has stayed the same on there, that means its voltage has actually increased. So the voltage on the resistor, on the 20 ohm, oops, get rid of that, it's confusing, and that, on the 20 ohm resistor has increased. Now realize that the total voltage stays the same. That's 12 volts. So if we subtract from that the 20 ohm resistor, which is going to be bigger, that means the voltage on R, which is here, must be less. Now that might seem confusing as to why that's less, but realize that even though the total current has increased, the 20 ohm resistor is getting the total current. The current going through here is split. So the current through this resistor is less. Now voltage is proportional to current, V equals IR. So if current has increased, then voltage increases, and that's what's happened over here. But on the right, because of the dividing of the current, even though it's increased, it's going to still be less because of the splitting. So the current has decreased here, so the voltage has decreased here. And that's kind of the way you'd explain it. And once you have an understanding of how voltage and current work together like this, it will really help you.